The next thing we're moving into with this math is stoichiometry. Stoichiometry is just the general term for all of our math, where we're going to use the relationships that are found in chemical equations and use the coefficients in the balanced equation in order to solve for some different information. You've already done grams to moles, particles to moles, volume to moles. We're just going to take that one step further and be able to switch it from grams, particles, liters of one thing to grams, particles, or liters of another thing. The first step in doing this is being able to go from moles of one thing to moles of another. So if you look at this example equation right here, you have a balanced equation with 1N2H4 plus 2H2O2 gives you 1N2 plus 4H2O. Another way of saying that is that you have 1 mole of N2H4, 2 moles of H2O2, 1 mole of N2, and 4 moles of H2O. This information can be used then to convert from one mole to another. So if you know the balanced equation, you can convert from moles of one thing to moles of another. So there you have three examples here. For all of them, you follow the exact same rules that we've been following whenever we've done any other conversions in class. You're going to read through the problem, write down what's given, in this case 2.25 moles of NH4NO3. So you're going to put that down here first, put times in a line. You want to get rid of moles of NH4NO3, and the problem's asking you to solve for moles of N2O, so you're going to put that up top. Where the ones come from here is you look at the coefficient in the balanced equation. There's one NH4NO3, there's one N2O, so that's where these two ones come from. Obviously then, 2.25 times 1 divided by 1 equals 2.25. For the second example, you have how many moles of water can be formed from 2.25 moles of NH4NO3, again using the same balanced equation that's up here. This time you write down exactly what's given, the 2.25 moles again. 1 mole of NH4NO3 goes in the bottom. Again, 1 mole because there's a 1 as the coefficient here. And 2 moles of H2O up top because there are 2 H2Os in the balanced equation. You multiply the things on top together, you get 4.50 moles of water. For the last one here, we have a different balanced equation. We want how many moles of O2, and we're given 3.45 moles of water. So we start by writing down our 3.45 moles of water, times in our line, moles of water on the bottom. If you look in the balanced equation, there are 2 moles of O2 up top. There's 1 up here. Because the 2 is on the bottom, you're doing 3.45 divided by 2, which is 1.725 moles of oxygen. Now you just need to try the ones that are on the back of the sheet.